In this lesson, we will be comparing between an acid and a base. When dissolved in water, acids produce hydrogen ions, while bases produce hydroxide ions. Hydrochloric acid, sulfuric acid, nitric acid, and ethanoic acid are some examples of acids. Examples of bases include sodium hydroxide, potassium hydroxide, and aqueous ammonia. Next, let's look at where acids and bases lie on the pH scale. This is a universal indicator. A universal indicator gives different colors in solutions of different pH. The pH values of acids range from 0 to 6, while the pH values of bases range from 8 to 14. The pH of a solution is related to the concentration of hydrogen ions or hydroxide ions present in a solution. pH 7 is neutral, which means that at this pH, the concentration of H plus ions is equal to the concentration of OH minus ions. The lower the pH value of a solution, the acidic it is, which means that it has a higher concentration of H plus ions. On the other hand, the higher the pH value of a solution, the less acidic it is. Solutions with high pH values have a lesser concentration of H plus ions, but will have a higher concentration of OH minus ions. For example, strong acids like hydrochloric acid, sulfuric acid, and nitric acid have pH values between 0 to 2, while a weak acid like ethanoic acid has a pH value of between 4 to 6. Aqueous ammonia, a weak alkali, has a pH value of about 10 or 11, while a strong alkali like sodium hydroxide will have a pH value ranging between 12 to 14. Acids turn moist blue litmus paper red, while bases turn moist red litmus paper blue. As you can see, lemons, which contain citric acid, turns moist blue litmus paper red. On the other hand, soaps, which contain bases, turns moist red litmus paper blue. There are three reactions of acids that we need to know. The first is acid-metal reaction. Acid and metal will react to give salt and hydrogen gas. For example, dilute hydrochloric acid will react with zinc metal to give zinc chloride salt and hydrogen gas. The second reaction is acid-carbonate reaction. Acid and carbonate will react to give salt, carbon dioxide, and water. For example, dilute sulfuric acid will react with calcium carbonate to give calcium sulfate salt, carbon dioxide, and water. The final reaction is acid-base reaction. Acid and base will react to give salt and water. For example, dilute hydrochloric acid will react with magnesium oxide to give magnesium chloride salt and water. An additional thing that you need to know about bases is that bases that are soluble in water have a special name given to them, and they are called alkalis. There are two reactions of alkalis that we need to know. Firstly, alkali reacts with an ammonium salt to give a new salt, ammonia gas, and water. For example, sodium hydroxide will react with ammonium chloride to give sodium chloride salt, ammonia gas, and water. Secondly, alkalis react with acid to give salt and water. For example, sodium hydroxide reacts with dilute hydrochloric acid to form sodium chloride salt and water. This reaction is also known as neutralization reaction. The ionic equation for this reaction is H plus and OH minus to give H2O. This is a very important ionic equation that you must know.